Hey everyone, Corey here with MindfulBit, and today we're going to be prepping for programming interviews. So there's this really nice book out there called Cracking the Coding Interview, 189 Programming Questions and Solutions. It's been really popular for programming interviews for the last few years. I used it 7 years ago or so, and it's still just as relevant today as it was then. So what I'm going to do is start a little video series here and go through the different questions, solve the questions in these videos, and just talk about it so that we get the experience and we can sort of learn this stuff together. So it's always good to brush up on these skills and to go through stuff like this just to make sure you're staying current. And a lot of data structures and algorithms that you may not use in your day-to-day working life, well, you still need to know those just in case you're interviewing in the future, or a solution might come up where those particular data structures or algorithms might come in handy. So today we're going to be working on the first question in chapter 1, 1.1, implement an algorithm to determine if a string has all unique characters. So this is the book. As you can see, I've got it marked up like crazy. Because there is just a lot of good information in here, and I really do highly recommend it. So get this book if you want. Otherwise, just continue to watch this series. We'll go through everything ourselves. So the very first thing is, let me go ahead and type this question inside of our IDE so that we can see it. So they want us to implement an algorithm to determine if a string has all unique characters. And then it also says, what if you cannot use additional data structures? Okay, so this will be similar to your coding interview. If you're interviewing for a job, they'll open up a coder pad and they'll typically type the question for you, just like this, and they'll type it as a comment so that you can reference it. And a lot of times they'll give you input and output so that you know what they expect, and they might even give you the method signature as well. But this one we're going to keep pretty open. I'm going to go ahead and write our main method here so that we can test. So the thing that jumps out to me when I see this question is a hash map. And she does say, what if you cannot use additional data structures? This is an additional data structure. Using a hash map, I would iterate through the string, and each time I encounter a letter, I'll put it in the hash map, and then I'll check every time I encounter a letter if it exists in the hash map. If it does exist in the hash map, then I will return false, otherwise return true. So let's go ahead and implement that solution first. We'll say public boolean is unique, and this is going to take a string. Okay. So what we want to do first is say if word.length equals 0, well, I'll return false. It's an empty word. There's nothing in here. We'll have that as false. Also, if word equals null or word.length is 0, we'll return false. Otherwise, let's go ahead and initialize our hash map. What we want this to be is a hash map of, let's see here, we want the Java version of the hash map. There we go. And we want this to be character. Actually, we'll do an int because we'll call the hash function of the character, and then we'll just put in the character itself. And we'll call this character map. Alright, so now we've got our hash map initialized here. And there we go. So now what we want to do is say for character C in Word, this is going to iterate through every single character. for character C in Word dot chars for character C in Word. I basically just want to iterate through there we go. We'll convert it to a character array. And what we'll do is we will say if charMap.contains key C.hashcode, then what we'll do is return false. Else we're going to add it, charMap.put C.hashcode, and we'll add the actual character itself. Now you don't necessarily need to add the character. We could use something like a hash set that is just integer, and then check that set to see if it contains it. That would be more efficient. So maybe we'll do that after we finish this. So we're going to go ahead and put that in, and then if we make it all the way through, what we can do is return true. Okay, so now we can call. We'll make this static so that we can call it without having to instantiate a main object. And we're going to print out is unique of the word test. Let's run this guy and see what we get. So what I expect to see is false returned because there are two T's in the word test. So let's let it compile. We'll see what output we get. Alright, we got false. So now let's remove the T and just do TES and see what we get. We should get the word true returned since it is unique. Nice. Okay, so that's one solution that you can use. And another thing you can do is you can say, okay, well, is this an ASCII string or a Unicode string? You can sort of guess if the string is longer than 128 characters for ASCII, then you know that it contains a duplicate, right? So if it's greater than the number of potential letters, then you can automatically know just by checking the length that the string contains a duplicate. So we can add that check in here pretty easily. We'll say if word.length is greater than 128, or word is null, or word.length is 0, return false. So we can also change this to a hash set, which only needs integer, and do the same thing. And then we check contains, set.add. So this should be a little bit more space efficient and optimize our space, because now all we are storing is the actual hash value of the character itself. So this one is a little bit more efficient than using a hash map. We're using a hash set, which is a little bit more efficient there. It works really well for when you're trying to determine if you've encountered something before. So this is one potential solution. The book talks about a couple of other solutions, and I just want to briefly discuss those here. One solution that is recommended in the book is to create an array, basically a bit array that keeps track of whether or not you've encountered the letter before. So you would initialize an array of size 128, and each character that you run into, you would access that index in the array, And if the flag has been set to 1, then you know you've encountered that particular letter. If it's 0, then you know you're good. So that's one solution as well that uses an array implementation. And then there's a solution that she recommends. She says we can reduce our space usage by a factor of 8 by using a bit vector. We will assume in the below code that the string only uses the lowercase letters A through Z. This will allow us to use just a single int. So I want to go through this one and code it just because this one is confusing for me. So we'll call this one isUnique bit vector string word, and we'll just code up the solution. So there's something called a checker here. She then has a for loop, integer I on the 0, I less than string.length, and I++. And inside of this, she says int val equals str. We'll do word.character at I minus A. Okay, so we'll see what exactly that's doing in just a second. Because honestly, I'm not sure. It looks like she's subtracting the ASCII value of the letter A from the current character. So then she says if checker and bitwise AND operation 1 val open is greater than 0, return false. Checker one val. Okay. And then she does a return true. So what this code is doing isn't entirely obvious to me. I'm going to be honest with you. So the best thing you can do is code it up and then just step through it with a debugger. Try to figure out what's going on. And I don't really use this operation that often. So I'm going to Google that real quick and find out what that is. Don't ever be scared to do that. So I found on Stack Overflow, what does the, I think that's just basically an or equals operator do in Java. And the answer is, this is a bitwise OR assignment operator. It takes the current value of the left-hand side, bitwise ORs the right-hand side, and assigns the value back to the left-hand side in a similar fashion to what plus equals does with addition. So it's a bitwise OR operator. So if you have two bit masks, basically, you can OR them together and you'll get the result. So we'll step through that and see what it looks like with the debugger. So let's call this here. And let's step through it. Let's see if it starts to make a little bit more sense as we step through the code. So I call it our method. Now I'm just running the debugger here. And we set a breakpoint right here on the first line at 18. And we'll see that word is equal to test. Now we're going to be iterating over each character in word. So value is going to be equal to 19. Okay. So this is the word.character at I, which is t. T minus a is going to give us 19. If checker and, so this is one I'm not familiar with. Let me double check the open less than sign on Google as well. Like I said, I don't want you guys to be intimidated when you see stuff that you don't know. Just look it up, you know. So this is basically, this means to left shift the bits. So it left shifts. Okay. If red equals 4, then red left shift bit 16 will insert 16 0 bits at its right. Okay. So you're just going to basically be inserting bits to the right. It's a left shift of the bits. Okay, that makes sense. So we're going to take 1 and we're going to left shift it by 19. So let's see what that looks. If we take this value here and copy it, we can evaluate it and see what we get. Okay. So 524288 is what 1 left shifted 19 times looks like. And that is a 19, that's, I believe that's in binary. So is that greater than 0? Return false, okay. So we just did the T, now we're going to go on to the E. And value is going to be equal to 4. Okay. Checker is equal to that number. And 1 bitwise shift 4. Let's evaluate that. Gives us 16. That's good. That's what I would expect. So if you have 1 and then you add 4 zeros to the right of it, you end up with the value 16. And that's in binary. So 1 0 0 0 0 is the value 16 in binary. It goes 1 2 4 8 16. Yeah, that makes sense. So when we had 1 with 19 zeros, that was the binary number for 5,200, whatever that value was. So now that we have this 16, if checker ended with 16, is greater than 0, return false, and it shouldn't be. Okay, so let's do the S. We'll see what we get there. And we're back to a T. So this is the one that I'm interested in because I want to see what it actually looks like. So value should go back to 19. Checker now contains a binary representation for everything so far, because I think they've been ORed together. So we should get a false here. Yeah, and we did. So that still will take some time to go through and really try to understand what these operations are doing. Really try to get a handle on, you know, these bitwise operations, because you don't use those very often when you're coding in the real world, honestly, unless you're writing some very, very low level libraries. It's very rare that you're going to use any of these bitwise operators. But take some time, go over this, maybe code it up yourself, step through. I'm going to do the same off video just to get a bigger handle of what's going on. But we do see what is happening here. They're taking the value, which they're using the character value minus A, and then they are adding that many zeros to the right of 1 and comparing that with the checker. Okay, and then if it's there and the AND is greater than 0, which means, you know, some of the bits were the same, then we return false. Otherwise, we update the value of checker to contain these new bits that we created for this particular letter. So that's question 1.1, a couple of different options to solve it. The last one being one of the most complicated. There are a few alternatives that are discussed in the book. One, you can compare every character of the string to every other character of the string, which is very inefficient. That will take big O of n squared time, which is similar to bubble sort algorithm, if you're familiar with that. So this is basically a bubble sort, except you're comparing characters. So I think that'll be it for this video. Question 1.1 and cracking the coding interview. Thank you guys so much for watching. I hope this was beneficial to you. And like I said, don't be scared to dive in. You're never going to know everything. A misconception is that as a developer, I should know everything that I see in these books or online or when I encounter something new, but that's not the case. The thing you need to do is know how to be a problem solver, know how to figure stuff out on your own. Don't be scared to code it up and step through it. Try to figure out what's going on. So that's the main takeaway for this question. And happy solving, you guys. Remember, this is what the book looks like. You can get it off Amazon. Do check it out, and I'll see you all on the next video. Thank you guys so much for watching. Bye-bye.